Have you ever wondered how an AI comes up with its answers? You ask it to write a poem, generate an image, or even diagnose a medical scan, and it just does it. But what's really going on inside that digital brain? The truth is, for many of the most advanced AIs, we don't entirely know. It's a huge puzzle known as the black box problem. Imagine a simple AI, like one that decides if an email is spam. It looks for keywords, sender reputation, and other clear signs. We can trace its logic step by step. But modern AIs, especially those using deep learning and neural networks, are vastly more complex. These networks are inspired by the human brain, with billions of interconnected neurons. When we train them, we feed them massive amounts of data, say, millions of cat photos. The AI adjusts the connections between its neurons over and over until it gets really good at identifying cats. Here's the tricky part. After all that training, we have an AI that's a cat spotting genius. But if you ask it why it thinks a specific image is a cat, it can't tell you. We can't simply look at the code and see a rule that says if it has pointy ears and whiskers, it's a cat. Instead, the knowledge is spread across millions of tiny, interconnected mathematical values. It's a web of logic so intricate that it's practically unreadable to humans. The AI has developed its own internal representation of catness, and it's not in a language we can understand. This isn't just a quirky academic problem, it has huge real-world implications. Think about an AI that helps a judge with bail decisions or an AI that recommends a medical treatment. If these systems make a mistake and we can't understand their reasoning, how can we fix them? How can we trust them? If an autonomous car makes a split-second decision in an accident, we need to know why it made that choice. Without transparency, we can't ensure fairness, accountability, or safety. So, what are scientists doing about it? This is where the field of explainable AI, or XAI, comes in. Researchers are developing clever techniques to peek inside the black box. One method is to create heat maps on images. For an image recognition AI, a heat map can highlight the specific pixels it focused on to make its decision. For a cat photo, it might light up the ears, whiskers, and eyes, giving us a clue about its thought process. Another approach is to build simpler, interpretable models that try to mimic the behavior of the complex AI. Think of it like creating a simplified summary of a very long, complicated book. This summary model can give us a good enough explanation for the big AI's decision, even if it misses some of the finer details. We're also training AIs to explain themselves in natural language, though this is still in its early stages. The ultimate goal is to build AI systems that are not only powerful, but also trustworthy and understandable. We want AIs that can work with us as partners, not as mysterious oracles. As AI becomes more integrated into our daily lives, from our smartphones to our hospitals, cracking the code of their decision-making isn't just a scientific curiosity, it's one of the most important challenges of our time. The journey to understand the AI mind is just beginning, and it's a quest that will shape the future of technology in our society. If you found this topic interesting, hit that like button and subscribe for more deep dives into the world of AI. See you in the next one.